Genre: expository text. Essential question: how do the Earth's forces affect us? Forces at Work by Beverly Harris. Chapter 1. Forces. A force pushes or pulls. Forces affect how objects move. You see forces working all the time. Caption: when you push someone on a swing, you use a force. A door swings open when you push it. A grocery cart moves if you push it. A door closes when you pull it shut. A drawer opens if you pull it. Caption: pulling is a force too. Gravity is a force. It pulls objects. On Earth, gravity pulls objects toward the ground. Gravity even pulls you. You can test gravity. Drop a pencil. What happened? It fell. Why? Gravity pulled it down. It's true. Gravity works. You proved it. Caption: gravity makes the baseball fall towards the ground. Friction is another force. It affects how things move. It is different from gravity. Friction happens when two objects rub against each other. It slows down moving objects. Caption: friction between the mug and the table slows down the mug's movement. Picture labels: pushing force, friction. Chapter 2. Friction at the Park. A park is a good place to see friction at work. Suppose a girl sits at the top of a slide. She starts to move. Gravity pulls her down, but the fabric of her clothes rubs against the slide. There is friction between the two surfaces. It slows her down. It changes the girl's speed. Caption: a smooth surface creates less friction than a rough or bumpy surface. What if children play on the soccer field? They kick a ball. A kick is a push. It makes the ball move. As it moves, the ball rubs against the grass on the field. There is friction between the grass and the ball. It makes the ball slow down. Caption: the ball moves faster over short grass than long grass. Friction also protects the children as they run. Their shoes rub against the ground. The friction keeps the children from slipping. Caption: cleats on soccer shoes create more friction between the ground and the shoe. Suppose a soccer player kicks the ball in the air. Friction and gravity are both at work now. Gravity pulls the ball back toward the ground. Friction between the ball and the air slows the ball down a little bit. Caption: the player kicks the ball, pushing it up. Chapter 3. Friction and Stopping. A skater's movement also shows how friction works. Skates have smooth wheels. They roll easily on the path. There is friction where the wheels go over the path. Without the friction, the skater would slip and fall. Caption: friction between the ground and the skate helps a skater push off. The skater makes more friction when trying to stop. The skater lifts the toe of the skate up, then puts the rubber stopper at the back down. The stopper drags on the ground. Friction between the stopper and the path causes the skater to slow down. Then he or she comes to a stop. Caption: Friction helps a skater stop safely. Forces work when a boy rides a bike. He pushes on the pedals. The pedals turn the wheels and the bike moves. When the boy wants to stop, he uses the brakes. This makes friction. The boy squeezes the brakes. The brakes grab the wheels. Then the pads rub against the wheels and cause friction. The bike's speed changes. The bike slows down and stops. Caption: Pushing with more force would make the bike move faster. Chapter 4. Less friction. Sometimes we want things to make less friction. Think about a football. The ball has pointed ends. These help it go through the air without much friction. A player throws the ball. The ball zips through the air like a rocket. Caption: A football's shape helps it move faster through the air than a round ball. At a swim meet, swimmers wear caps to cover their heads. They wear suits to cover their bodies. The caps and suits are slick and smooth. Now there is less friction between the swimmers and the water. The swimmers can swim fast, like fish. Forces are at work everywhere you look. What examples can you see? Caption: Swimmers at the 2008 Olympic Games wore special suits to make less friction. Machines to push and pull. Gravity gives objects weight that we can measure. Heavy objects are hard to move, but machines can help us work against gravity. Amazing. Table. Force. Push. Pull. Force. Moving a grocery cart. Push. Force. Playing tug of war. Pull. Force. Hitting a baseball. Push. We can use machines as tools to help us push and pull heavy objects. Some machines are very simple. Ramps. Some machines use inclined planes. An inclined plane is a flat surface that is raised on one end. A ramp is one example. It's easier to move a heavy object by sliding it up a ramp. Caption: Using a ramp helps these workers move a piano safely. Levers. A lever is another kind of simple machine. A lever is a bar that rests on a support. The support is called a fulcrum. A force is applied at one end of the bar. This lifts the load at the other end. Levers help lift heavy things. A wheelbarrow is one kind of lever. Caption: The man applies force when he pulls up on the handles of the wheelbarrow. Picture labels. Force. Load. Fulcrum.